This is a tweet, and well, I guess it's a good tweet. It tries to be funny and make light of a very bad situation, but that's not exactly what this video is about. At least not on the surface. Well, it kinda is. Icebergs are diminishing now, and humans are just kind of to blame for that. Unless the methane in cow farts is keeping you up at night, then you can mention those too. But we'll mention them anyway. By the way, I really feel like my way of adding to something to the conversation is through the means of other than how the cycles work. So get ready, it's gonna go fast. So here is the definitive list. 4 different cycles, a problem of 2 farmers, and the human impact of everything. The carbon cycle. Plants take in CO2 during photosynthesis, animals release it via respiration, and dead organisms break down through decomposition. Combustion of fossil fuels adds CO2, while oceans and forests act as carbon sinks. Carbohydrates and water store CO2 and excess nutrients, causing eutrophication, disrupting the balance. And for the human aspect here, the melting of the permafrost releases that cow gas, methane, a potent greenhouse gas, but it's also a massive amount of stored carbon. Also, cement production. It accounts for over 8% of the global CO2 emissions, according to ASU. This happens during the heating and extrication of limestone. With some glaring similarities to the carbon cycle, the oxygen cycle. Plants release oxygen during photosynthesis. Animals use it for respiration, and dead matter breaks down through decomposition. Combustion consumes oxygen, and while oceans and forests serve as oxygen sinks, oxygen dissolves in the water, forming oxides, and eutrophication affects oxygen levels, altering the cycle. The burning of fossil fuels is also a major human impact, reducing air quality and also significantly affecting natural ecosystems and vegetation. This issue is complex, as it literally is better explained by socio-economic factors like urban housing prices and the real estate investment practices. Nonetheless, this is biology. The water cycle. Water evaporates from surfaces. Plants release it through transpiration. It cools into condensation. Precipitation falls, leading to runoffs into rivers, lakes, or oceans. Eutrophication is when this runoff enters natural water bodies, and this collection occurs in natural reservoirs. Dam construction and drought conditions and increased evaporation are all side effects of this. Another concern is the industrial cooling using river waters as it impacts natural life. While practical, these methods raise questions about sustainable alternatives. The nitrogen cycle. Okay, I'm going to slow down on this one. Nitrogen fixation turns atmospheric nitrogen into ammonia, which is converted to nitrates and assimilation. When organisms die, ammonification returns nitrogen to the soil. Denitrification releases nitrogen back into the air. And eutrophication, ecosystems' response to the addition or introduction of substances, occurs when excess nitrogen disrupts water ecosystems. Forest fires release stored nitrogen from vegetation and soil, disrupting those local nitrogen cycles. Widespread fires, like those in California, can have far-reaching environmental impacts. Waste incineration, particularly of plastics and food waste, also contributes significantly to nitrogen. And finally, the phosphorus cycle. It's probably more important than you think. Phosphate mining extracts inorganic phosphorus found in rocks and fertilizers. Erosion breaks those down, releasing phosphorus into soil and water. Plants absorb organic phosphorus, which cycles through organisms. Inorganic phosphorus is not yet part of living organisms. Well, organic phosphorus is. Leaching moves phosphorus deep into soil or water. Uplift exposes buried phosphorus, and eutrophication happens when excess phosphorus harms water ecosystems. Animal agriculture, specifically cattle farming, has a significant impact on phosphorus cycles. While cow manure can be beneficial for soil health, erosion control, and water retention in dry areas, improper management can lead to water system contamination, particularly in areas with high concentrations of animal farming. Similarly, food processing industries often lack incentives to monitor and control phosphorus and their wastewater output. These are serious issues that do not currently possess a material issue for many of us today, but completely furnish the ability to be severe and chronic issues for those of tomorrow. That brings us to the problem of 2 farmers. But what's some application theory you might want? What can I do with this? Well, we have a situation actually. 2 aspiring farmers, Ms. Hines and Ms. Shuckers, decide to take control of their food supply by starting their own farm. Because, well, they already lost their house to the Canadian housing crisis and don't seem to have much else to work with. Their dream? Produce organic ketchup and jam, straight from their own tomatoes and strawberries. Fast forward a few months, their own little farm is thriving. Or so it seems. Yellow leaves. Use some fertilizer? Did it work? Yeah, a little too well. A dead fish floats near the surface, bound by a thick, ever-developing soup. They found eutrophication, and they found it one of the worst ways. Firsthand. It's innocent enough. Some well-meaning for the most things fertilizer doesn't just stay on the fields. Rain washes it to a nearby lake. Along with it, it brings nitrogen and some phosphorus. I maintain a fish tank, so while researching this, I had a hunch that it was making algae, but I didn't know until this point. I have 2 recommendations, and I hope they pick whatever they feel works best for them. Trying the concept of precision farming, where you use highly location-specific soil testing and some guided equipment from the likes of field drones and some smaller scale but still huge industrial operation management to find the best balance between effectiveness and the water management. During the next dormant season, create a divide when replotting between the lake and the fields around it with some native shrubs and trees, things that are higher up and can best absorb these nutrients before they make it to the water. But as I'm thinking ever more now, the best solution is probably somewhere in the middle. While I was developing this, I was staring at this and ended up finding that was their solution here. Thanks for watching. I'm Ethan Bradley, developed, shot, and edited by me. Thanks for watching.